Okay, so we start now section 5.1. So we start chapter 5. And we're back on more familiar territory. I mean, so ordering and the equivalence relations might be something that you might not have dealt much, depending on how far you are. But now we're talking about functions, so you should be quite familiar with them. So, and everything is closer to things familiar, right? So it should be a little bit easier. Any case, so in this problem, which is problem 10, we're asked to prove that we have a relation from A to B, R, and a relation S from B to C, in which the range of R is B, so all of B is in the range, and the domain of S is also B, so everything is in B is in the domain of S. And if, whenever you compose these two relations, the resulting relation is a function from A to C, then we have to prove these two things. First, that S itself, if the R and S are in principle just relations. The composition is a function. But if the composition is a function with these restrictions in here, then S itself has to be a function. And then you were asked to show that that's not necessarily the case for R. R is not necessarily a function. Okay? So let's do this. So let's do part A. So to show that S is a function, S is a relation, to show that it's a function, the first thing that you have to do is to show that this setting here is the domain. But this is given to us. Okay? Because in a function, relation does not necessarily have every single element of the first set. So if you have a relation here, it's not necessarily true that every single element in the first set is in the domain. It could be different. But it's not necessary for a function, okay? So this is saying the domain is B, but we have that. So maybe we should say that from the start. So note that by assumption, we have that the domain of S is B. So this would be the first thing we have to prove, but it's just an assumption in this case. So that was easy. Now, what we have to show, after we establish the domain, what we have to show is that note if there's only, so it's for S in here. So the B is only related to one C. A little b in capital B is related to exactly one C. Okay? So that's what we need to do in here. So let's try to do it by well, there are two ways to do it. I mean, we can assume that we have B related to, well, let me write this down. So suppose we have B C1 in S. Well, let me put them together. BC1 in S and BC2, both in S. Okay? So what I was trying to say before is that we have the same B in the first entry. So this would say that C1 is the image of F, and C2 is the image of C1 is the image of B, C2 is the image of B, but it's a function, so there's only one image for B. So what we need to show, let me put in parentheses in here, we need to show that C1 is equal to C2. Okay? So that's where we have to get, because that's a function. There's only one image for each element in the domain. All right. So of course, you should be looking for all your assumptions, because you have to use them all. I haven't used these, and I haven't used the fact that the range of R is B. So this is what's going to do the trick, because this has the same property. Some little a in capital A can be associated to only one little c in C. So that's where we're going to cook up this equality here. But what happens is that since range of R is B, by definition, we have that some little a B belongs to R for some little a in capital A, by definition of the range. So if you take anything in B, in particular this little b, so little b is taken for me, is this one in here. Okay? So taking this little b in here, there is some, because it's in the range, there is something in the domain of R such that AB is in the relation. Or if you wanted to, you could have just written A related to B, right? Okay. So, what happens then? So let's look at the composition S with R. Well, I have AB in R and BC1 in S. We have that then that AC1 is in the composition, right? You have the middle element matching here. So this is in R, this is in S, AC1 is in S. And the same thing for this other pair. Have AB, BC2, so I have that A, C2 are both in the composition of S with R. But this is a function, so the same element in the domain gives you the same image. So what we have is that C1 is equal to 2 as S composed with R. It is a, let me abbreviate function here, FCT, because we write often FCT for me is function. Okay, so that would be part A. We show the last thing for a function. We show the domain and then only one element associated with everything in the domain, or related with anything in the domain. All right, so now let's do B. So here we have to come up with an example where we have all these premises but are not a function. So here's an example. Let's take A to be the set that has only 1. Let's take B to be the set that has 1 and 2. And let's take C to be the set that has only 2. My relation R is going to be 1, 1, 1, 2. So notice that this is not a function. Because 1 is related to two different things. One is related to 1 and one is related to 2. Okay, both are in B. And notice that what is the range of R is equal to all of B, because we have 1 and 2 appearing in the second coordinates. Okay, so the range is B. Now let's look at S. S for me is going to be 1, 2, and 2, 2. Now note that this is a function, but I don't really care. I mean, it's not important. But that's, of course, coming from the fact that it has to be a function. In the end, I mean, because of course I'm cooking up a counterexample, the composition is going to be a function. So I don't need to observe that it's a function, but I do need to observe that the domain of S is all of B, because I have 1 and 2 on the first entries, right? Appearing in first entries. So we have this, we have this. And lastly, what is the composition? We have that S composed with R is what? Have 1, 1, and then 1, 2. So I have 1, 2. And I have 1, 2, and 2, 2. So gives me 1, 2 again. So I have 1, 2. Now this is a function. There's no repetition of elements in the first entry. And what is the domain of these? The domain is all of A. So this is indeed a function from A to C, right? From 1 to 2. And it is a function. But as you can see, R is not a function. So this is a counterexample of something that can go wrong in here. Okay, so R doesn't have to be a function, but S does. Okay, so that is problem 10 of section 5.1.